Okay, hello everyone. I am Dr. Ranganath Haridas, working as assistant professor in Sweris College of Engineering, Pandharpur. So for CET crash course, we are discussing different chapters. So for physics, today we are going to discuss one of the chapter, that is gravitation. So we will discuss some of the basic terms related to gravitation, and then we go for MCQ numericals related to the equations under this gravitation chapter. So let us start this one. So in case of gravitation, different points are there that we have to cover, and we will check this one by one. So first is gravitational field. What is meant by gravitational field? A region or space around body in which gravitational force is experienced by other bodies is called as gravitational field. So what is Newton's law of gravitation? Newton's law of gravitation states that every particle of matter in the universe attracts every other particle with a force which varies directly as the product of their masses and inversely as the square of distance between them. It acts along the line joining the two particles. So it is given by the equation capital F is equal to gmm divided by r square, which is equal to mg, or we can write the value of g as gmm divided by r square. So what it means? So gravitational field means what? A region or space around body in which gravitational force is experienced by other bodies. That is called as gravitational field. If we consider a particular body, then the surrounding of the body gets it's having this gravitational field which is experienced by the other bodies. In case of Newton's law of gravitation, what is the statement? Newton's law of gravitation states that every particle of matter in the universe attracts every other particle with a force which varies directly as the product of their masses, means it is directly proportional to product of their masses, and inversely as the square of distance between them. It is inversely proportional to square of distance between them. So here we can write this force as capital F is equal to gmm upon r square. ग्रॅव्हिटेशनल फील्ड म्हणजे काय? तर त्या बॉडीच्या अराउंड जे फील्ड आहे जे एक्सपिरियन्स करतं कोण? तर अदर बॉडीज एक्सपिरियन्स करतात, त्यालाच आपण काय म्हणतो? तर ग्रॅव्हिटेशनल फील्ड. न्यूटन्स लॉ ऑफ ग्रॅव्हिटेशन काय सांगतो? तर प्रत्येक पार्टिकल जो आहे मॅटरचा तो दुसऱ्या पार्टिकलला काय करतो? अट्रॅक्ट करतो विथ ए फोर्स. एका फोर्सनं. तो जो फोर्स आहे तर तो आपण कसा डिफाइन करतो? दिस फोर्स विच व्हॅरीज. तो कसा व्हॅरी होतो? तर डायरेक्टली ॲज द प्रोडक्ट ऑफ देअर मासेस. जे दोन पार्टिकल आपण कन्सिडर करतो त्या मासेसचा प्रोडक्ट, अँड इनव्हर्सली ॲज स्क्वेअर ऑफ डिस्टन्स बिटवीन देम. त्यांचं जे डिस्टन्स आहे त्याचा स्क्वेअर आहे तर तो इनव्हर्सली प्रोपोर्शनल असतो. हाऊ वी कॅन राईट इट? एफ इज इक्वल टू जी एम एम अपॉन आर स्क्वेअर. सो वेअर this g is nothing but universal gravitational constant. Its value is given here and its dimensions are also mentioned. Now what else related to this? The gravitational force is the weakest interaction between the particles. Then next point is the gravitational force of attraction between the elementary particles is negligible when compared to the other nuclear forces. Next, the work done by the gravitational force between the planet and sun is 0. Then the gravitational forces are conservative forces and attractive forces. Next, gravitational force is the weakest force in nature. It is about 10 raised to 38 times weaker than that of nuclear forces and 10 raised to 36 times weaker than the electric forces. Means here, if you can see the properties or the information related to this gravitational force, so it is the weakest force, which is the weakest interaction between the particles. Then this gravitational force of attraction between elementary particles is negligible as compared to nuclear forces. If we consider the work done by this force between the planet and sun, then it is 0. Then these forces are conservative forces. And if we compare this with other natural forces like nuclear force or electric forces, then it is much, much weaker than the other forces. So let us move to the next one, that is gravitational intensity. The strength of gravitational field at a point is the measure of gravitational intensity at that point. The intensity of gravitational field at a point at a distance r from center of the body of mass m is given by capital E is equal to F by m. That is, if we put the value of F, then we can get gm upon r square, or E is equal to simply g. The unit of intensity of gravitational field is n by kg and its dimensions are given as m0 L1 T minus 2. The value of intensity of gravitational field is 0 at infinity. So here we are discussing about gravitational intensity. So the strength of the gravitational field at a point, that is nothing but the gravitational intensity at that point. त्याची gravitational intensity असते. The intensity of gravitational field at a point where the distance we are considering, that is r from the center of the body, and if we consider the mass as small m, then it is given by the equation capital E is equal to F by small m, where after conversion we can get these values. Its unit and dimensions are given. Then next, acceleration due to gravity, that is g. It is defined as the acceleration set up in a body while falling freely under the effect of gravity alone. The value of g is 0 at the center of Earth and at infinite distance. The value of g on the surface of Earth is 9.8 meter per second square, and near the equator it is 9.78. At poles it is 9.83. The relation between small g and capital G, we can write it as weight of the body is equal to gravitational force acting on that body. So it is written as mg, which is equal to gmm upon r square. That is the relation. Now this slide gives us information about acceleration due to gravity. What it means, it is defined as the acceleration set up in a body while falling freely under the effect of gravity alone. जेव्हा आपण फक्त ग्रॅव्हिटीचा विचार करतो त्यावेळेस जे काय ॲक्सिलरेशन सेटअप होतं बॉडीमध्ये जेव्हा ती फ्री फॉलिंग बॉडी असते, तर that is nothing but acceleration due to gravity. Here we have to consider the gravity alone, not other effects. The value of g is 0 at the center of Earth and at infinite distance. Acceleration due to gravity ची जी व्हॅल्यू आहे तर ती 0 असते सेंटर ऑफ अर्थला, किंवा जर डिस्टन्स खूप जास्त असेल तर द व्हॅल्यू ऑफ जी ऑन द सरफेस ऑफ द अर्थ, तर ज्या व्हॅल्यूज आहेत जीच्या त्या वेगवेगळ्या आहेत. अर्थ सरफेसवर 9.8, इक्वेटरला असते 9.78 आणि पोल साईडला असते 9.83. And the last one is relation between small g and capital G. where this m is mass of planet, r is radius of the planet, m is mass of satellite, g is acceleration due to gravity. So this is an acceleration due to gravity on the surface of planet of mass m and radius r, that is g is equal to gm upon r square. Now for a body at height h above the planet's surface, how we can write? So we have to consider the additional height of that particular body which is above the planet's surface when we are considering acceleration due to gravity related to the Earth's surface or poles and equators. Now here, when we consider a body at height h above the planet of surface, then how we can write it? So it is mg which is equal to gmm upon, instead of r square now, we are adding this height as r plus h, it's a square. So it becomes gh, that is acceleration due to gravity at that height, is gm upon r plus h, it's a square. Thus, gs is less than g, that is acceleration due to gravity decreases as we go above the planet from its surface. So here we are discussing about the position of body which is above the planet surface, due to which what happens? Due to which in our equation we are adding r plus h, that is the height extra distance from the center of the earth, and we can get the new equation, that is gh, that is acceleration due to gravity at that particular height, is nothing but gm upon r plus h square. So as the value increases in the denominator, so you know that the value decreases here. So gh is less than g, that is acceleration due to gravity decreases as we go above the planet from its surface. So that ratio is given here. So we can use these equations during our MCQ or numerical discussion. The next variation of g just above the Earth's surface means just above the Earth's surface, if we consider the variation, then how we can write it? So if h is less than r, then value of g at the height is approximately given as gh is nothing but g into 1 minus twice h upon r. And variation of g with depth means if we consider the depth, then acceleration due to gravity related to depth is, we can write gd, which is equal to g into 1 minus d upon r. So two cases we are considering in this slide, that is related to height and related to depth. We are defining the equations. Then variation of g on the surface of Earth. So value of g on Earth's surface varies because of two reasons. First is due to shape. Earth is elliptical in shape. It is bulged at equator because of centrifugal force. Therefore, radius of Earth is maximum at equator and minimum at pole, as g is nothing but gm upon r square. So g is proportional to 1 upon r square for the same planet when mass is constant. Thus, acceleration due to gravity is minimum at equator and maximum at poles. So in the previous one, we have discussed about the just above the Earth's surface, variation of g, and depth. In this case, variation of g on the Earth's surface we are considering, where first case we are considering for shape. जर शेप किंवा शेप मुळे काय होतं ते आपण इथं चेक करतोय. अर्थ इज इलिप्टिकल इन शेप, वी नो इट इज bulged at equator because of centrifugal force. Therefore, radius of Earth is maximum at equator and minimum at poles. Then we can write this g as gm upon r square, or simply g is proportional to 1 upon r square. So for the same planet when mass is constant, same thing is there. Thus, the acceleration due to gravity is minimum at equator and maximum at poles. The next slide gives us what is meant by critical velocity. So it is the velocity required to put the satellite into a circular orbit around the Earth. Means when we are considering the position of satellite to set the satellite in the Earth above the Earth, then in that case we have to consider this term critical velocity. So what it means, it is the velocity required to put the satellite into a circular orbit around the Earth. Means when we consider the Earth and we are launching that satellite above the Earth's surface, then we are expecting that whatever we have decided in the orbit, so that particular satellite can set at that orbit successfully. So when that satellite starts rotating around the Earth in that orbit, then we fulfill the condition because of this critical velocity. That's why we are saying it is the velocity required to put the satellite into a circular orbit around the Earth. Orbital velocity of a satellite when it is revolving around the Earth of mass capital M, radius capital R, at height h is given by this mu square divided by r plus h, which is nothing but gmm upon r plus h, it's a square. So after adjusting the terms, we can get the value of Vc as r under root g upon capital R plus h, where we can calculate and fix the value of critical velocity. तर क्रिटिकल वेलोसिटी म्हणजे काय, तर अशी वेलोसिटी जी रिक्वायर्ड आहे कशासाठी, तर आपण जेव्हा सॅटेलाइट लॉन्च करतो तर तो जी पृथ्वी आहे त्याच्या ऑर्बिटमध्ये सर्क्युलर ऑर्बिटमध्ये फिरत राहायला पाहिजे. That critical velocity is given by the value as r under root g upon r plus h. By using this equation we can get this value. Next, time period of satellite. It is the time taken by a satellite to complete one revolution around the Earth, where that value is given by capital T is equal to 2 pi into r plus h divided by Vc. So we can write this as 2 pi divided by r under root r plus h, it's a q by g, by considering the value of Vc. So after considering this, we can get this equation. As t square is proportional to r cube, so graph of t square and r cube is a straight line passing through origin. The slope of the graph is constant. So here we have to consider this relation when we consider the time period of satellite. The time period of satellite म्हणजे काय, it is the time taken by a satellite to complete one revolution around the earth. असं टाइम की त्या पृथ्वीच्या भोवती त्याला एक कंप्लीट रिव्होल्यूशन जे आहे ते करण्यासाठी वेळ जो लागतो त्यालाच आपण काय म्हणतो, तर टाइम पिरियड ऑफ सॅटेलाइट. नेक्स्ट पॉइंट इज एस्केप velocity. So what it means, minimum velocity with which a body should be projected from surface of a planet to reach to infinity is called as escape velocity. It is given by v is equal to under root twice gm upon r, as gm is nothing but g into r square. We get v is equal to simply under root 2gr. So in this case, when we consider this particular factor, that is escape velocity, so we will complete the remaining point first and then we discuss it. Greater the value of escape velocity from a planet, denser will be its atmosphere. Value of escape velocity of Earth is 11.2 km per second. Value of escape velocity of Moon is 2.31 km per second. Value of escape velocity in case of Jupiter is 42 km per second. So from this you can guess that depends upon the size and gravity or gravitational force, what the escape velocity is requirement, it gets changed when the conditions gets changed. There is no atmosphere on moon because the RMS velocities of the molecules are greater than the escape velocities. That is the additional information. If the velocity of a satellite is increased root 2 times or by 41.4%, it escapes out from the earth because its velocity becomes greater than the escape velocity. तर escape velocity आपण डिस्कस करतोय where first we have discussed what it means. Minimum velocity with which a body should be projected from surface of planet to reach to infinity is called as escape velocity. कमीत कमी velocity जेणेकरून ती जी बॉडी आहे तर ती जर प्रोजेक्ट केली कुठून फ्रॉम सरफेस ऑफ प्लॅनेट टू रीच टू इन्फिनिटी म्हणजे काय त्याच्या ग्रॅव्हिटेशनल फोर्सला क्रॉस करून जर ती इन्फिनिटीला जाऊ शकत असेल तर ती जी मिनिमम वेलॉसिटी तिला आपण म्हणतो एस्केप वेलॉसिटी. बाय इक्वेशन्स वी कॅन राईट दिस स्टाईल. तर वेगवेगळे जे प्लॅनेट्स आहेत त्याचं कम्पेअर केलं तर आपल्या लक्षात येईल की जी एस्केप वेलॉसिटी आहे तर तिची व्हॅल्यू काय असते, वेगवेगळी असते. देर इज अ नो ॲटमॉस्फिअर ऑन मून. हे मॉलिक्युल्सशी रिलेटेड सांगितलं एस्केप वेलॉसिटीची व्हॅल्यू किती असते. आणि जर आपण वेलॉसिटी इन्क्रीज केली सॅटेलाइटची तर ती ऑलरेडी जर एस्केप वेलॉसिटीपेक्षा जास्त असेल तर आपल्याला परत तेच रिझल्ट मिळणार आहेत. मीन्स इट कॅन दॅट बॉडी कॅन एस्केप टुवर्ड्स द इन्फिनिटी. नेक्स्ट, जिओस्टेशनरी सॅटेलाइट. The communication satellite is also called as geostationary satellite. It appears to be stationary when observed from the Earth because its period is same as that of the Earth. It is also called a geosynchronous satellite since it coincides with the spin of rotation of Earth. A satellite whose time period is same as that of the time period of the Earth above its own axis, that is 24 hours. The satellite is at a height of nearly 36,000 kilometers above the equator and 42,000 kilometers from the center of the Earth. It is a satellite moving in equatorial plane west to east. It is used for communication such as television broadcasting, weather forecasting, military purpose to study cosmic rays and solar radiations. So geostationary satellite means what? The communication satellite is also called as a geostationary satellite. Means if we consider the Earth, then this satellite is set at certain height from the Earth. So what are the conditions why it is called as stationary though it is moving? It appears to be stationary, that's why it is called as a geostationary. Why it appears stationary? When observed from the Earth because its period is same as that of the Earth. Means we have synchronized the rotation, we have synchronized the revolution period of that satellite around the Earth in such a way that it takes 24 hours for complete revolution. Means from any position, if we see the satellite, then we feel that it is just above our head. Anytime we can see that satellite. The reason is that we know the rotation period of Earth is 24 hours, and if we maintain the same condition for that geostationary satellite, then this happens. That's why it is also called as geosynchronous satellite since it coincides with the spin of rotation of the Earth. त्याला आपण geosynchronous satellite असं सुद्धा म्हणतो. A satellite whose time period is same as that of the time period of the Earth above its own axis. that is 24 hours. The satellite is at height of nearly 36,000 km above the equator and 42,000 km from the center of Earth. तर जवळपास त्याची जी स्टँडर्ड व्हॅल्यू आहे ती आहे 36,000 km. It is a satellite moving in equatorial plane west to east. It is used for different purposes. We are using this communication, such as television broadcasting, then for weather forecasting, military purpose, then to study the natural phenomenon like cosmic rays, solar radiation, etc. So we can use this geostationary satellite for different application. For that, we have to understand what is meant by this gravitational field. Then and only then we can set this successfully to the required orbit. Next, weightlessness. Weightlessness in a satellite. Feeling of weight is due to the reaction force exerted by the surface of the Earth. The weight of a person is maximum on the surface of the Earth. The astronaut in an orbiting satellite feels weightless. The apparent weight of body is 0, but actual weight can never be 0. So it is given as apparent weight of the body is nothing but actual weight of the body minus weight of the body due to the acceleration. That is mg minus ma or m into g minus a. So here this weightlessness in a satellite we are considering. So feeling of weight is due to which factors? The reaction force exerted by the surface on the earth. आपल्याला जो फोर्स एक्झर्ट केलेला आहे तर त्याच्यामुळेच आपल्याला वेट फील होतं. द वेट ऑफ पर्सन इज मॅक्झिमम ऑन द सर्फेस ऑफ द अर्थ. इट इज मॅक्झिमम. द ॲस्ट्रॉनॉट इन अन ऑर्बिटिंग सॅटेलाइट फील्स वेटलेस. जो ॲस्ट्रॉनॉट सॅटेलाइटमध्ये आहे त्याला वेटलेसनेस जाणवतो. The apparent weight of body is 0, but actual weight can never be 0. So here, due to that state where gravity works less, and if we achieve that condition, then weightlessness in satellite is observed or experienced. Weightlessness is observed only in an artificial satellite, but it is not observed on a natural satellite like Moon because it has its own gravity. Then next is freely falling body. A body is said to be a freely falling body when it falls under the effect of gravity of the earth alone and the effect of all other forces is negligible. A freely falling body is one which falls with the acceleration due to gravity. So first thing we have discussed, that is weightlessness. That is because the setting some conditions. So here that point is added that this happens in case of artificial satellite, not in case of natural satellite like moon. त्यानंतर कुठला पॉइंट आपण चेक करतोय? फ्रीली फॉलिंग बॉडी. ए बॉडी इज सेड टू बी फ्रीली फॉलिंग बॉडी. आपण त्याला फ्रीली फॉलिंग बॉडी का म्हणतो? when it falls under the effect of gravity of the earth alone. Means when that body is falling freely, then only the gravity of earth is the effect of that free falling and the effect of all other forces is negligible. बाकीचे जे forces आहेत तर ते negligible असले पाहिजेत. A freely falling body is one which falls with the acceleration due to gravity. Of course, it requires or fulfill this condition. So now we have to discuss the numericals MCQs related to this. So let us revise this one in short once again. So we have started with the gravitational field. Then what is meant by Newton's law of gravitation. In that we have compared this gravitational force with the other natural forces, its value, how it is the weakest one amongst other all. Then gravitational intensity, its unit dimension. Then g, that is acceleration due to gravity, its value on the surface of earth, near equator, near pole. Then next one is when we consider the body at a particular height from the earth's surface, or we can consider the distance from the center of the earth. Then we can get some equations. Then variation of g just above earth's surface, variation of g with depth. So as height changes, as depth changes, we got the new values. And variation of g on the surface of earth due to shape of the earth, which is elliptical. So it is different at equator and pole. Then critical velocities, which is a required velocity to put satellite into circular orbit. Time period we have considered. Then escape velocity to escape from the gravitational force or from gravity of that respective planet like Earth, Moon, Jupiter, etc. Then geostationary satellite. Geostationary satellite म्हणजे काय, त्याच्या काय conditions आहेत and how we can use that for different purposes. Next is weightlessness in a satellite and free falling body. So we consider some of the MCQs related to this gravitation chapter. First, let us start with when bodies of masses 1 kilogram and 25 kilogram are separated by a certain distance, the resultant gravitational field in between them is zero at a point which is 1 meter from 1 kg. Then the distance between them would be. So here we have to use the equation that is m1 upon m2, which is equal to x divided by r minus x, it's a square. So what are the values given to us when bodies of masses, इथं काय सांगितलंय, बॉडी जे आहेत दोन त्याचे मासेस दिलेत, एक आहे 1 किलोग्राम, दुसरा आहे 25 किलोग्राम. सो m1 upon m2 we are getting 1 divided by 25 are separated by a certain distance. एक certain distance ना आपण त्याला सेपरेट केलेला आहे. The resultant gravitational field in between them is zero. Resultant zero hai at a point which is 1 meter from 1 kg. 1 kg pasun te 1 meter ahe. Then the distance between them would be. So after calculation, we can get that r is equal to 6 meter. That is option B is the correct one. Next, acceleration due to gravity at Earth's surface is 10 meter per second square. The value of acceleration due to gravity at the surface of a planet of mass 1/5 and radius 1/2 of the Earth is. So here two conditions are there. Acceleration due to gravity is given to us, and the value of acceleration due to gravity we have to calculate at the surface of the planet where its mass is 1/5 and radius is 1/2 of the Earth. So when we compare these things by using equation of G, so G2 upon G1 is nothing but M2 upon M1 into this R1 by R2, it's a square, where we can write this value as 1/5 into 4 by 1. And after calculation, we can get the terms as G2 is equal to 4 by 5 into G1. After calculation, we can get the value of G2 as 8 meter per second square, which is our option C. The next, a body of 200 kilogram weight is lying in the surface of the earth. Find its weight at a place R above the surface of the earth. Radius of the earth is capital R. So here you can see, first we have to check what are the given things. A body of 200 kilogram weight, 200 kilogram weight जी body आहे तर which is lying on the surface of the earth. Find its weight at a place R above the surface of the earth. त्याचं weight काढायचे कुठं, R above the surface of the earth. प्लेस दिलेले R, पण R म्हणजे काय तर रेडियस ऑफ द अर्थ आपल्याला कन्सिडर करायचे. तर आपल्याला इक्वेशन माहिती r divided by r plus h, it's a square, that is the relation. So from that we can determine the value as 200 by 4, which is equal to 50 kg weight. तर ह्याचा आन्सर येते. Next, two planets are of the same material but their radii are in the ratio 2:1. Then a ratio of accelerations due to gravity on those two planets is. काय दिले आपल्याला? Two planets are of the same material. Material is same, but their radius is different. Its ratio is 2:1. So here we are considering that value, that is 2:1. Then the ratio of acceleration due to gravity on those two planets is. So how we can determine the ratio of acceleration due to gravity? So we know the relation g1 upon g2 is nothing but rho1 upon rho2 into r1 upon r2, where we are saying that of same material means the rho1 and rho2 is same, so it becomes 1. Radii ratio is 2:1, so 2 divided by 1. So simply by considering this, we can get the ratio of acceleration due to gravity as 2:1. This is the solution for this. Next, if g is acceleration due to gravity on the surface of the earth having radius r, the height at which the acceleration due to gravity reduces to g by 2 is. म्हणजे काय तर g acceleration due to gravity आहे कुठे on the surface of the earth, radius आहे capital R. तर काय काढायचं आपल्याला? the height at which the acceleration due to gravity reduces to g by 2 is. म्हणजे अशी हाईट की जिथं acceleration due to gravity काय होते? हाफ होते. Different options are there. So we know the relation g2 by g1 is nothing but r divided by r plus h. It's a square. So here we know the relation, that is g divided by 2g, which is equal to r divided by r plus h. It's a square. याला जर आपण रिमूव्ह केलं स्क्वेअरला तर इथं काय होणार? 1 upon under root 2, g cancels each other, r divided by r plus h. If we solve and simplify this one, then we can get the value as h is equal to r under root, sorry, h is equal to r in bracket under root minus 1. So that is one of the option, that is r in bracket under root minus 1. So by considering this equation, we can solve this MCQ easily. Then next, the depth from the surface of the earth where acceleration due to gravity is 20% of its value on the surface of the earth is. So r is given as 6,400 kilometer. We have to determine the depth. The depth from the surface of the earth where acceleration due to gravity is 20% of its value on the surface of the earth. म्हणजे काय तर अशी कुठली डेप्थ आहे कुठून फ्रॉम द सर्फेस ऑफ द अर्थ जिथे ॲक्सेलरेशन ड्यू टू ग्रॅव्हिटी किती आहे तर 20% आहे. पण कशाचे 20% आहे? ऑफ इट्स व्हॅल्यू ऑन द सर्फेस ऑफ द अर्थ. जी सर्फेस ऑफ द अर्थची व्हॅल्यू आहे त्याच्यापेक्षा 20% ग्रॅव्हिटी ज्या डेप्थला आहे तर ती डेप्थ आपल्याला काढायची. त्याच्यासाठी रिलेशन आपण बघितले, दॅट इज जी डी इज इक्वल टू जी इंटू 1 मायनस डी अपॉन आर. So here after simplification we can get the value as 5120 kilometer, because this GD is nothing but the 20% of the original G. So if G is 1, then GD is 0.2. 1 minus D upon R is given to us. So if we simplify and calculate this, we can get the value as D is equal to 5120 kilometer. So 5,120 kilometer is the option B, which is correct one. Next, radius of earth is around 6,000 kilometer. The weight of a body at height of 6,000 kilometer from earth's surface becomes. So here we have to consider this equation, that is W2 upon W1 is equal to R divided by R plus H its square. तर इथं H किती आहे? Rच आहे, कारण का इथं आपल्याला काय म्हटलेलं आहे? Radius of Earth is around 6,000 kilometer. The weight of body at height of 6,000 kilometer from Earth's surface becomes. So this H is nothing but R once again. So this R divided by R plus R divided by 2R its square. So it is simply 1/4. So here, if we compare this, so W2 is nothing but W1 by 4, or W by 4 means 1/4 of the initial one. So that is the solution. Next, two satellites of masses 50 kg and 100 kg revolve around the Earth in circular orbits of radii respectively 9R and 16R, where R is the radius of Earth. The speeds of the two satellites will be in the ratio of. तर याचा जो स्पीड आहे, ऑफकोर्स क्रिटिकल व्हेलॉसिटी मध्ये आपल्याला ऍडजस्ट केलेले. तर याचं रिलेशन आपल्याला माहिती पाहिजे. Vc1 अपॉन Vc2 इज नथिंग बट अंडर रूट R2 बाय R1. तर इथं काय दिलेले आपण चेक करू. टू सॅटेलाइट्स ऑफ मासेस, दोन सॅटेलाइट आहेत ज्याचे मासेस आहेत 50 kg अँड 100 kg, रिव्हॉल्व अराउंड द अर्थ इन सर्क्युलर ऑर्बिट्स. सर्क्युलर ऑर्बिट्स मध्ये रिव्हॉल्व करतात, ज्यांचे रेडियस काय आहेत? 9R and 16R respectively. 9R and 16R respectively, where R is the radius of Earth. R काय radius of the Earth आहे, त्यामुळं ह्यांचे जे सर्क्युलर ऑर्बिट्स आहे तर ते 9 into radius of Earth आणि 16 into radius of Earth एवढं आहे. The speeds of the two satellites will be in the ratio of. त्या दोघांचा जो स्पीड आहे त्या दोन सॅटेलाइटचा, त्यांचा रेशो आपल्याला काढायचा आहे. त्यासाठी आपल्याला क्रिटिकल व्हेलॉसिटी आणि रेडियसचे रिलेशन माहिती पाहिजे. सो Vc1 upon Vc2 is nothing but under root R2 by R1 by comparing the equation of Vc. So we know it is 9R and 16R. So after simplification, we can get this as 4 by 3, which is option B. Next, a satellite of mass m is at a distance r from the center of the Earth. Another satellite of mass twice m is at a distance of 2r from the Earth's center. Then their time periods are in the ratio. याचे जे टाइम पिरियड्स आहेत तर त्याचा रेशो आपल्याला काढायचा आहे. तर त्याच्यासाठी आपल्याला हे रिलेशन माहिती पाहिजे. टी स्क्वेअर इज प्रोपोर्शनल टू आर क्यूब, जे आपण चेक केलं मागाशी. So T2 upon T1 is equal to under root R2 by R1 raised to 3 by 2. So value of R2 is 2R and R1 is R. हे आपण दिलेले. A satellite of mass m is at a distance R from the center of Earth. Distance है R from the center of Earth. Then another satellite of mass 2m, twice m असलेलं mass आहे त्याचं distance जे आहे ते twice R आहे from the Earth center. तर त्यांचा जो टाइम पिरियड आहे त्याचा रेशो आपण काढतोय. त्याच्यासाठी आपण या व्हॅल्यूज दिलेल्या आहेत. सो ट्वाइस आर बाय आर रेज टू 3 by 2. सो आफ्टर सॉल्विंग we can get the value as T1 upon T2 is equal to 1 divided by 2 root 2, or 1 as to 2 root 2. That is the answer. Then next, two satellites are orbiting around close to the Earth in circular orbits with same period. One of them is 100 times greater in mass than the other. The radii of the orbits are in the ratio. So here once again we are writing R1 by R2. मगासारखंच आहे, फक्त आपल्याला R1 आणि R2 चा रेशो काढायचा आहे. तर त्यासाठी आपण इथे काय दिलंय? Two satellites are orbiting around close to the Earth in a circular orbits with the same period. Same time period आहे. One of them is 100 times greater in mass than others. इथं काय संबंध नाही त्याचा. The radii of the orbits in the ratio. त्याच्या रेडियस साठी आपल्याला टाइम पिरियड आणि रेडियसचं रिलेशन माहिती. इथे टाइम पिरियड जर सेम असेल तर किती पण मास वेगळा असेल त्याचा काही फरक पडत नाही. So after solving we can get the answer is 1:1. The next, if the escape velocity of the Earth is 12 km per second, then what would be the new escape velocity if radius of the Earth shrinks to 1/4 of present value such that its density does not change. तर इथं एस्केप व्हेलॉसिटी दिली अर्थची 12 किलोमीटर पर सेकंड. जर त्याची न्यू एस्केप व्हेलॉसिटी आपल्याला काढायची असेल, कंडिशन काय, तर त्याची रेडियस श्रिंक झाली, कमी झाली. किती झाली ती 1/4 झाली. आणि डेन्सिटी आपण सेम आहे अशी कन्सिडर करतो. तर डेन्सिटी सेम असल्यामुळं ρ1 ρ2 सेम येणार. इथे सिम्पली काय काढणार आपण, VE2 डिवायडेड बाय VE1 इज इक्वल टू R2 बाय R1 अंडर रूट ρ2 बाय ρ1. सो इट इज सिम्पली 1/4. हा जो रेशो आहे ना तर 1/4 येणार आहे ॲज इट इज. सो VE2 इज इक्वल टू VE1 अपॉन 4. VE1 ची व्हॅल्यू आपल्याला माहिती ती किती, 12 किलोमीटर पर सेकंड. 12 बाय 4 3 किलोमीटर पर सेकंड. म्हणजे थोडक्यात काय, तर जेव्हा अर्थ आहे तर त्याची रेडियस जर 1/4 श्रिंक झाली तर जी एस्केप व्हेलॉसिटी पहिल्यांदा 12 किलोमीटर होती ती किती होणार आहे, तर 3 किलोमीटर पर सेकंड. देन नेक्स्ट, the radius of the earth is capital R. For a satellite to appear stationary, it must be placed in orbit around the earth at a height near about. तर इथं काही गोष्टी आपल्याला माहिती पाहिजेत. फॉर जिओस्टेशनरी सॅटेलाइट वी नो द व्हॅल्यू ऑफ H, आपण 36,000 म्हटलेलं. तर इथं एक्झॅक्टली म्हटलं तर आपण इथं हाईट आहे 35,870 किलोमीटर. सो H इज 35,870 किलोमीटर. So if we know this value, then we can determine these things. For that, these two things we have to know: the radius of the earth. The radius of the earth is standard, that is 6380. So if we put these values, we can get the answer. So expected is that these values are known to you or it is given in the MCQ, then you can solve it. So it is 5.62 R, that is the placement of that particular satellite at that height, which is 5.62 times than the radius of the earth. So these are some of the MCQs related to this gravitation. So let us conclude this now. So we have started with the gravitational field, then Newton's law of gravitation, in which different conditions we have discussed. Gravitational intensity म्हणजे काय हे आपण बघितलं. Then acceleration due to gravity. Acceleration due to gravity जे आहे, how we can define it. So acceleration is set up in the body while falling freely under the effect of gravity alone. फक्त ग्रॅव्हिटीचा कन्सिडर करतोय आपण इफेक्ट. कशावर, तर जेव्हा ती बॉडी फ्री फॉल होते त्यालाच आपण म्हणतो ॲक्सलेशन ड्यू टू ग्रॅव्हिटी. त्याच्या व्हॅल्यूज आपण बघितल्या वेगवेगळ्या पोझिशनला अर्थच्या. त्यानंतर त्याचं इक्वेशन. देन ॲट अ सर्टन हाईट हाऊ वी कॅन राईट इट, मॉडिफिकेशन ऑफ इक्वेशन. त्यानंतर जीची व्हॅल्यू जस्ट अबावर सरफेस काय असते, डेप्थमध्ये काय असते, ऑन द अर्थ सरफेस काय असते, शेपमुळं ती कशी होते. त्यानंतर क्रिटिकल व्हेलॉसिटी म्हणजे काय हे आपण चेक केलं की अशी व्हेलॉसिटी की ज्याचा यूज करून आपण सॅटेलाइटला सर्क्युलर ऑर्बिटमध्ये सेट करू शकतो अराउंड द अर्थ. देन एस्केप व्हेलॉसिटी जी आहे ती आपण बघितली. एस्केप व्हेलॉसिटी म्हणजे काय, तर अशी व्हेलॉसिटी की जेणेकरून तो जो सॅटेलाइट आहे किंवा ती जी बॉडी आहे तर ती एस्केप होईल इन्फिनिटी, टुवर्ड्स इन्फिनिटी. दॅट इज द एस्केप व्हेलॉसिटी. त्यानंतर जिओस्टेशनरी सॅटेलाइट. जिओस्टेशनरी सॅटेलाइट मीन्स the satellite which we can consider when we see above our head, then we can see that satellite 24/7 because it is a geosynchronous satellite. It is coincides with the spin of the rotation of the earth. So its standard height is 36,000 kilometer from the surface of the earth if you consider, or by adding the radius of the earth it is 42,000 kilometer. So it is used for different purpose and applications. Then weightlessness in satellite for the astronaut, free falling body, and then different MCQs we have discussed. So we have tried to complete the maximum basic terms and some of the MCQs related to that. We conclude here. Thank you.